Okay, before we go further with long run analysis, I would like to correct myself a bit, which is kind of embarrassing because I was teasing you about forgetting thing, and at the end I was the one who said the wrong thing first. Yeah. So I said the part of the short run marginal cost curve above the average short run average cost curve is the short run supply curve of firm, which is not wrong, but not precise neither. So it's actually started somewhere below that, where the short run marginal cost curve cross the short run average variable cost. Now, so if you go back to that video when we were talking about the short run supply of firm who are price takers, then you will see that. Just one small thing, however, it can get confusing, especially when we talk about marginal and average cost a lot in the upcoming session. So just for you to be aware of. Now let's go. Now we can talk about long run analysis. Let's first point out a difference compared to the short run analysis that we had before, which are the different assumptions now. Most of the cases you know already, I think. So firms may adapt all inputs to market conditions. Meaning what? So remember, before when we talk about long run and short run costs, we also said that in short run, now I abbreviate it as SR, K capitals typically assumed to be fixed at a certain level K1. Nah. So it's assumed that in the short run firms cannot change the level the degree of capital investment that flexibly. Therefore, now we don't look at the short run marginal cost curve to determine the output level as we did before with the short run case anymore, but we have to look at the long run MC. That's one thing. Another thing I also mentioned when we introduced to this is entry and exit of firms allowed. So this is one important key difference compared to the short run case. In perfect competition setup, we assume that firms can freely enter and exit the market with no extra cost. So in general, firms will enter when profits are earned or positive. So if people see that some industry making money, then of course they would like to jump in. On the other hand, if people are losing money in one certain business, they would like to quit. That's natural thought. Now, how about when profit is exactly zero? What happens? Now, those who's in the market will remain in the market, and those who's out of the market will remain out of the market. Why? I will talk about it a bit later when we have some more idea about market equilibrium in long run already. Now, we also came across this before, that is entry and exit ships short run supply curves. And why do we talk about short run supply now? We're talking about long run analysis now. So the idea is, just think about it this way. A long run is just a collection of multiple short run periods. One after the other. Yeah. So in short run, we only focus on one period, and now because these factors allow to change or to shift, then we could say what to change from one short run period to the other period. That's the idea. Go back to this input cost a little bit. So you may think, okay, what is the implication for the input market if firm can freely enter an exit market? Would that have any impact on the input price? If you're thinking along that line, then you're going on the right track. Now, it's a little bit complicated here. That make a problem that we have to take care of is there's three cases. Now, so cost, okay, cost can stay constant. That means independently of the number of firms or how much more demand arising for input from these entering firms, the input price stay the same or constant now, not depend on the quantity produced by this industry. Of course, it could depend on other factor, but we assume it's constant with respect to the output quantity of the industry and the number of firms. Okay, it could also be increasing, meaning the more output the industry wants to produce, then the more demand pressure on the input market, and that will increase input price. And then of course it will have different implications for the long run equilibrium that we're interested in for this industry. And the third case, we have also decreasing cost. We're talking about input. Okay, so for this long run analysis, we will look at these three cases one after the other. Now, to repeat again, in long run equilibrium, profits are zero. Why? Because there are no incentives for firms either to enter or to exit or to get out of the market now. So there is an equilibrium number of firms at that long run equilibrium together with the equilibrium price and equilibrium quantity, output quantity. These are the things that we're interested in knowing when we carry out long run analysis. Okay, so we got the important assumption. Now we can talk about equilibrium conditions. The first is price equal marginal cost. This is familiar to us already because we also had that in the short run analysis, but with the short run marginal cost. Now we look at the long run marginal cost, but still it's the same. Price and marginal cost must be equal, which is implied by profit maximization. However, because we said that profit at the long run equilibrium must be zero, another condition is needed, which is price equals the long run average cost. Then a third condition, because we were talking about the firm now, so we would also be interested in knowing the number of firms, usually denoted as N, at the long run equilibrium. the formal definition. So a perfectly competitive market, always keep in mind we're talking about perfectly competitive market with certain assumptions, is in long run equilibrium if there's no incentive for profit maximizing firms to enter or to exit the market. And that happens when we have an output level which make the market price equals the marginal cost equals also the average cost of the firm. When I talk about firms here, assume that's a typical average firm of this industry. And there's a small writing there in the bracket saying that this is only possible at the minimum of long run average cost. Luckily, fortunately, we have talked about that also. If you wonder why, then go back to the video where we talk about short run versus long run cost. And that was before the Christmas break, I think, and where I explained a bit mathematically why the marginal cost curve crossed the long run average cost curve at the average cost curve minimum. So it has to be at that point the minimum point of the long run average cost curve. Let's start with the first case where we have constant cost. So that means that the input price will remain the same with increasing or decreasing number of firms in the industry. That doesn't have any impact on the input market of the industry now. So on this graph, currently we have a short run market equilibrium. So SS mean short run supply. And why we start with the short run? Because like I mentioned, a long run period is just simply many short run periods put next to each other. So we look at the first period of that now, where the market equilibrium, short run equilibrium is at Q1 and P1. This is where the short run supply curve cross the demand curve of the market. And at that price, firms use the short run marginal cost curve to determine its output quantity small q1, the normal q1, where market price and short run marginal cost the same. So that's what we know already. Okay. Now here's the new thing. That quantity and price P1, Q1 will also be the long run equilibrium if AC, the long run average cost curve, and MC, the long run marginal cost curve, cross that point. And of course, like said before, if that's the case, then that must be the minimum point of the average cost curve here. So that point is actually important. We have seen that also in the when we talk about cost, production and supply, right? One important thing to notice at this point is when is the long run equilibrium, meaning the profit is zero. Why profit is zero? Because you would have total revenue when firms produce at this Q1 times the price P1. That's the total revenue. And what is the cost? Because at this point, your average cost curve crossed that point. So average cost equals P1, right? And then your total cost will be AC times Q by definition. And plug in this one in, you will have TC equals P1 times Q1. And which is exactly the same as total revenue. So at that point, your profit is 0. And this is the difference compared to the short run equilibrium before, but I come back in a second to that when we see the next movement. Now assume for some reason demand shifts outward. For example, income increases and demand for car will also increase, like we have seen with the previous example. What will happen in the short run? Price will increase because now short run supply responds to the shift of demand by moving up to this new equilibrium point. Note here, we're still talking about a short run equilibrium point. And what is the implication for the firm? Going back here at the new equilibrium price P2. By the way, market equilibrium quantity now is Q2. At this price P2, of course, firms will move up along the short-run marginal cost curve to determine its quantity Q2, Q small 2, where price and short-run marginal cost curve meet each other. That's the new one. Now firm has profit. So that's why I said in the short run, firm can earn profit from the shift in demand. Why? Because now at this quantity, your revenue is P2 times Q2, right? Let's denote as TR2. But your cost is TC2 equal Q2 times AC2. And where's AC2? Now it's here, right? Because the AC curve is now below the short-run marginal cost, so it will be smaller than TR2. Consequently, P2 will be positive. Where's the profit then? So this is the profit. The P2, okay? However, that's not the end of the story. If you move up to the next period, now that we consider the short-run period when the demand shift, but nothing happens afterward, what's the next happen then? As soon as their economic profit in the industry now, the other firms not yet in the market will see or will sense this profit. Of course, it makes the industry attractive to them. Then what happens? New firms enter the market, right? And in previous slides, we said when new firms enter the market, the demand, the short run Sorry, not demand, but the short run supply curve shifts outward. So this is exactly what happened here. And they will keep entering the market until there's no profit. So it go back exactly to the level, to the price level P1 as before. However, now with Q3 larger than Q2. And only at that point, when profit becomes zero again, it will stop. So there is no new firm entering, but also no firms exiting the market. And that's the new, we could say that here, new long run equilibrium. Now, so that's the story. And if you connect these long run equilibriums after so many shifts like that, you get a long run supply curve. And in this constant cost industry case, it's just a vertical line. Sorry, not vertical, but horizontal line. Meaning the equilibrium, maybe it's not so good to write it there. So meaning long run equilibrium price is always P1. Why is that the case? One thing to remember is because the input market is not impacted by the numbers of firms in the industry. These three cost curves will stay the same there. If you wonder why, go back to cost minimization and profit maximization. So there's no shift, no change in this cost curve. They will stay there. Consequently, at the point P1, where the marginal cost and the minimum of average cost meet, is always the profit, the zero profit point. So now if firms, I don't know why, just maybe because of the Vietnamese language, I keep saying firms, but it's firms, I mean firms, if I say it wrongly the next time. So if firms keep entering the market after this point and shift further, and then somewhere below here, profit will be zero. So of course, when profit not zero, but profit will be negative, they will make loss. And because of that, they will get out of the market again until price reach this point again. But one last thing to think about. If you look at this long run supply curve, do you have any idea about its elasticity? From the slide, we talk about how supply elasticity is when there's demand shift. So the flatter the supply curve is, meaning it is more elastic. And in this extreme case, when it's horizontal line, then it's infinitely elastic, meaning the quantity can adjust infinitely without altering the market price. So this is one very special case. I can't even think about one example. Which market is that? Maybe beer again. If you have any idea, then I would be happy if you share with me. All right. Let's do one example for the long run equilibrium with the constant cost case. Here we have a demand function, market demand, which is given by QD equals 1,500 minus 50p. We also have a typical firm's cost function, which is the short run cost function now, because remember we started every situation with a short run supply curve. So that's why we needed a short run cost function, which is given by C equals 0.5q squared minus 10q plus 200. Let me write it down clearer here. Short run cost function mean without entry or exit. Now the task for us is how, given this assumption, to find the long run LR, equilibrium price quantity, both supply of firm and supply of the industry, and the number of firm at this long run equilibrium. Now, there's more tasks coming, but let's first just start with this. The first thing to remember is in long run equilibrium, price crosses the average cost at the minimum of average cost curve. So that is one important point to find out. There we need the minimum of average cost curve. And if we want that, we need the average cost curve first. So AC equals C divided by Q. That we know equals. Now this is the short run cost. However, it will also cross there. So 0.5 Q squared, sorry, Q, because we divided by Q already, right? Minus 10, and then plus 200 divided by Q. That is the average cost. So the minimum AC require that from FOC we have the derivative of AC with respect to Q equals. Why we could use AC here, another reason is because we have constant cost case, so cost doesn't shift. That's why this is also one way to find the average cost. Okay, which is now the derivative is 0.5 plus, not plus, sorry, minus 10 is gone, so the derivative of 200 over Q is 200 over Q squared with the minus in front, equals 0. And we could solve for this condition, meaning 0.5 equals 200 over Q squared, meaning 0.5 Q squared equals 200. And then there we could solve step by step. Q squared equals 400. Divided both sides by 0.5, and at the end we have Q equals how much? 20. Then now go back. Okay, when Q is 20, then AC reaches minimum, sorry. But how much is that minimum? So So we could plug Q back into the AC to find AC mean equals 0.5 times 20 minus 10 plus 200 over, sorry, yes, it's Q, but now let's write 20, which is 0.5 times 20 is 10, minus 10 is gone, and then plus another 10. So that at the end, AC mean equals 10. I should frame it so that we don't mess it up somewhere. Okay. And the equilibrium condition required that at equilibrium, one of the condition is P equals AC mean, right? It's equal AC, but that's equal MC, and that's only at AC mean. So that is P start equals 10. Also, very nice. We found one, actually two, because Q, the quantity for form, we found already. Yeah. The next long run supply of industry. How to find it then? Now let's use the very basic equilibrium condition, which is QS equal QD. Yeah. Equals, we have P already, P start, we could plug into the QD function to find the Q equilibrium, which is 1500 minus 50 times 10. So that means Q start equals 1500 minus 500, 1000. And the second. Done, done, done. Now the last thing we need is the number of firms, which is easy, right? We have Q, large Q, we have small q, and we assume that forms identical. Right now, number, I'm writing in German actually, number of firm N equals Q start divided by Q start equals 1000 divided by 20, and meaning N equals 50, right? Let's put a start here also. Then we finish at least with this task. The next step is to see what happens when demand shifts, like on our slide. But for that we would need a few things, so let's derive it first. The first thing is the short run marginal cost curve. That will be derivative of C with respect to Q, right? So that would be 2 times 0.5 Q minus 10. That is the short run marginal cost. We will also have the short run supply, where we set SMC equal P, right? That's the condition for short-run supply. And we have at MC here, so we could just plug it in Q minus 10 equal to P. And this is the inverse supply, right? Because we're writing P as a function of Q and something. Function. Therefore, we would need to transfer it to the normal supply function of form, which is Q equals P plus 10. Let me highlight it. And then we have, yeah, okay. This is for firm, right? And then we have short run supply of industry, which is sum of n the supply of the firms, right? And here we, before that, remember we have n is 50. So, and the firms assumed to be identical, like before. So that is 50 times P plus 10, and that would be 50P plus 500. This is industry supply. Like that. Okay. Now QS. Let's write it here. QS. Now we have what we need for the next step. So the next step would be a demand shift. Let's write it here. Demand shift to QD equals 2000 minus 50P. So that is a shift outward, right? Because before that we have 1500. Then the task is to find very short run, and long run equilibrium. So we see what happens in different episodes of the story, like what we always did before now. Make boundary. Sorry, I'm a bit messy. Whatever. Now, for very short run, what happens? The basic assumption is for very short run supply is fixed. At how much? Before shift, the supply quantity that we found, let's write this here, QS star that we found earlier was 1000, right? So here it should also be, 1000. This is for very short run. Therefore, the condition for equilibrium now is QD. Let me say QD new equals QS start. So that means 2000 minus 50p equals 1000. And that would mean we could solve for p. 50p equals 2000 minus 1000, 1000. What's the remaining? No? And then p start very short run would be 1000 divided by 50. No? That is 20. So the good thing is for math we don't need that much here. We just need to know where to put the assumption of the problem set in. So you have to pay attention to what I'm doing, but then you will be fine. And then for short run, what is the core assumption? No new form. Enter. Meaning we still have n, not n equals 50, right? So we would have QS short run equals QD new. That means the total supply of the industry is the same short run supply curve as before. Oh, sorry, this is not. This is the demand, but the short run supply curve is this short run, this one that I just derived here. Now, so here let's denote it as short run. So QS short run equals QD new. Then we have 50 P plus 500 equals 2000 minus 50p. And that means now we could put all the p's to the other side, 100p, and the numbers to the other side, 2000 minus 500, 1500. And that means p star short run equals 1500 divided by 100, easy, no? 15. That's what we have. And from this new short run equilibrium price, we could also find Q as short run equals plug P back into this short run supply 50 times 15 plus 500, which is 1250. That is total industry supply when demand shift. The next thing we would do is firm supply. So QI short run would be QS short run divided by N, and N stay the same, right? 50. So that means here is 1250 divided by 50. At the end we have Q short run equals 25. This is for the short run new equilibrium once demand shifted. Okay, let's continue. So the next is to find the new long run equilibrium after many episodes of adjusting. So on the other hand, I have summarized what we have done so far with once the demand shifted to this new demand in this table now. We have number of firms, new price, industry supply, firm supply for very short runs, like immediately, short run, and long run. Short run. Okay, better. Now, what I have filled in here, it was actually a previous step that we have found out, but the pink color, the number in pink color is what is fixed. And in green colors, what changed after the demand shift for very short run and short run. Now let's find out for the long run, what will happen. So for the long run, because this is a constant cost case, you remember after adjusting to the new long run equilibrium, what remains the same for the constant cost case? P. So P start stay the same, which is here, constant, right? So you could fill in here already. For the long run, P is constant, 10 in pink, already good. And then we continued having P. We could already plug in the demand and supply to find the industry supply quantity, right? So that is Q new equal QS new equal QD new. Could plug in QD, for example the new QD, 2000 minus 50 times 10, which is now equals 2000 minus 500, 1500. This is Q star new. Let's frame it. So we could fill in here, because now Q stars 1500. What we know theoretically is it will be higher than the Q star before, right? So that is true because Q star in the old equilibrium is 1000. So that changed. We have 1500. And then the next step is for let's say N to find, but first of all we need Q star. Oops. Q small, firm supply, new, which is 20. Why? Firm supplies 20. Why do I know that? Because actually it stays the same as its initial equilibrium. Because AC and MC don't shift. So it's actually AC mean is still 10, right? Equal P start, that doesn't change. And that means that it must be Q equal to 20 when AC mean, as we derived with the first order condition of the AC before. Constant cascade, not changing. So actually this is not new, but it's the same thing. So we could fill in here is 20. Doesn't change. However, number of firm will change because now we have Q star new divided by, this is new, divided by Q start, can drop the new, that is 1500 divided by 20, which is 75. So this is new. So you can see again that for the constant cost case, when the demand shifts outward, then the number of the firm stay the same in the short run at first, but then increases later. The price will increase in a very short run because supply was fixed at first. However, it decreases gradually down to the original level at the long run. And Q, similar, will increase. Not similar, but on the other way around, the industry supply will increase. First, in a very short run fixed, no increase at all. Second round, when number of firms not adjusted, but firm could increase their output, then the total output of the industry increases and price also decrease. And then at the last round, when the new equilibrium long run is established, the industry supply got the highest. And then this firms also, the supply per firms pre-adjusted to the original, but the number of firms increases. So that's the idea of the constant cost case.